Okay, this one's about unit vectors. So just to get started, I'm just going to remind myself, what is a unit vector? So every vector has length and direction. And, well, not the, but, and unit vectors. And unit vectors, well, what are they? Unit vectors have length equals 1, okay? And then I'll say to normalize means to shrink a vector to unit length. That means length 1. Okay, so there's my words, just sort of reminding me what's happening. And now I'll draw a quick little picture. So V1 is in a one-dimensional space. And here it is. It's going to go 3 units to the left. Because you see it up here. It's just, well, it's a vector in one-dimensional space, because there's one number, and it has, it goes to the left by 3. Then I'll now draw V2. So this is V1. And now V2 lives in a 2-dimensional space, and it goes left by 3 and then up by 2. So I'll just sort of roughly sketch it. This is V2. And I'll write it as a column. Okay. And then I'm not going to do any more pictures than that, because the other ones are harder. So now I'll just do formulas. Oh, maybe I'll add one more thing to the picture. So this would be V1 hat. And this would be, this is V2 hat. In other words, it's the unit vector. So I label that in my picture, just, it's the vector that has the same direction, but unit length. Length is 1. Okay. Now I can compute. So V1 hat equals V1 divided by the length of V1. Well, V1 is just -3, and the length of V1 is 3. So V1 hat is this vector, -1. What about V2 hat? Well, V2 hat is just V2, but divided by its length, so that the result will have length 1. We're sort of removing the length, or we're normalizing the length. What's V2? It's -3, 2. That's a vector. I'm going to divide it by a number. What's the number? Well, this number is, so now I have to remember the formula. The length of a vector is the square root of v dot v. Okay? And so, in this case, this vector dot itself would be, let's see, -3, 2, dot -3, 2. Well, that's 9 plus 4. And so this will be the square root of 13. And so, V2 hat is a unit vector. It's this vector. I like to keep the scalar outside because otherwise it's too hard to write something like this. It's just, there's too much going on inside the components of my vector. But either one is fine. V3 hat, now what's V3? V3 was this vector. Okay, so I just need to find its length, so its dot product with itself is I think that's right. And so it's just going to be 1 over square root of 62 times v3. So this is the formula, the vector itself divided by its length. Last one, it's going to be the vector itself. That's v4. Now I have to just divide it by its length, so I need to put something down here. And that number will be 9 plus 4 plus 49 plus 1. It's 50 plus 13. I think it's like that. Okay, so this was an important formula that helped me decide how to scale my original vector, how to shrink it from there down to there. In this case, v2 is quite literally